This is A2Pure and we're in Unit 2, so we're still running through our trigonometry, and we're going to take a wee look at graphs of inverse trig functions along with inverse trig functions. So sine to minus 1, which really you've been using for years in terms of working out right angle triangles and stuff, also been known then as arc sine x. Arc cos x is cos to minus 1 and arc tan x is tan to minus 1. The sine, cosine and tangent functions are periodic, as in, obviously remind ourselves of the graph. Periodic means it kind of comes back to the same point again and just keeps repeating. For the domain of real numbers, they are a many to one mapping. To define the inverse trig function, sine to the minus 1, cos to minus 1 and tan to minus 1, the domains for sine, cos and tan need to be restricted so that they're 1 to 1. Our problem is, because this starts to repeat itself, then we can't find the inverse. We can only find the inverse if it's going to be 1 to 1. So we have to restrict the domains in for each of these whenever we're trying to find in our inverse trig function. So for sine, we restrict the domain in between minus 90 and 90. If you take a wee look at this, there's the reason for it. We're going between here and here. If you go any further than any of those, the thing starts to repeat itself. So as it starts to go back down here, these points have already occurred, so we can't have that. So this is our best point to take it from, in between minus 90 and 90. Or as I have here, minus pi over 2 and pi over 2. So that's for sine. We'll chat about that in a wee second. For cos, we take then our domain between 0 and 180. So again, you can see there in those stages is it repeating itself. If we go back over there, we can't go minus 90 to 90 because there's lots of kind of repeated bits here. So it goes back over to that. So it remains between 0 and pi, or 0 to 180. And then for tan, we take then minus 90 to 90 again. Otherwise it starts to repeat itself. Using then these restricted functions, it says down here, y equals sine x, y equals cos x, and y equals tan x. They are now 1 to 1 functions. So at this stage then we can work out our inverse functions. These are quite hard to see, so we'll take a wee look. The graphs of sine to minus 1, cos to minus 1, tan to minus 1 can now be sketched by reflecting the graphs of y equals sine x, y equals cos x, y equals tan x in the line y equals x. Remember to use the same scale on both axes and to measure the angles in radians. So here's our wee bit of sine. If you remember, it was between minus pi over 2 or minus 90 and 90 degrees, and there's your sine graph. Remember, we'll just keep on going on like that if need be, but we've restricted the domain there in between here and here. So let's take a wee look. We're going to reflect it on y equals x, which is this line here. Again, quite hard to see. Remember, that's pi over 2. So pi over 2 then is going to appear on our y-axis whenever we start to reflect it. So let's take a wee look. So remember, we have pi over 2 here, so it's pi over 2 here. Remember, sine goes as high as 1, so the 1 bit then is going to appear over here, and this then is the way our graph looks. On the end of the cos one, remember again that we had restricted the domain of this between 0 and pi, or between 0 and 180 degrees with our 90 in here. The cos graph, if you remember, kind of starts like this, goes up like this, all the way over, with restricted domain between there and there. That makes us then 1 to 1. So we can reflect it in y equals x. Again, the y-axis effectively becomes the x-axis. So what's going to happen? We're going to go in between 1 and minus 1. And then we're going to go up the y-axis to pi over 2 then pi. So it looks like this. Reflecting it in the line y equals x, it's going to send this over here. So we have minus 1, 0 is a point, then 0 pi over 2, then our 1 minus 1, that's the other way around. Actually, it has to be 1, sorry. And then our minus 1 then over here. On then the tan graph. So here we have our domain in between minus pi over 2 and pi over 2. There's our regular tan graph, the way we would kind of know it. So again, reflecting this is going to change into pi over 2 is going to go to the y-axis, and the minus pi over 2 is going to go down to here. And we head in with that. Because of our asymptotes there's going to be an asymptote here, and going across here, and going across here then as well. So those are our 3 inverse trig functions.